Doctor, I can't understand what's going on. I feel dizzy and, how do I say it? I'm tilting. It didn't happen overnight. Like, I didn't wake up and couldn't stand straight. No, one day, I felt that my axis had shifted by 1 inch. Another day, it was 2 inches. And once, you won't believe it, it was 31.5 inches. That's alarming. What if I accidentally turned upside down and all my inhabitants fall off my surface? Ah, dear Earth. We ran some tests and are ready to explain an unfortunate combination of factors that has affected your axis. The last one will perhaps be the most unexpected and upsetting. It all started back in March 2011, when a devastating magnitude 9 earthquake struck off the coast of Japan. It was so powerful that not only did it shift Earth's axis, but it also shortened the length of the day. This earthquake displaced our planet's axis by approximately 6.5 inches and may have moved Japan's main island by about 8 feet. Like other similarly massive earthquakes, it also altered Earth's rotation speed. To make it easier, let's compare it to a spinning ice skater. When a skater pulls their arms close to their body, they spin faster by concentrating their mass near the axis of rotation. Something similar happens during the most powerful earthquakes. They shift Earth's mass closer to its rotational axis, causing it to spin faster and shortening the day length. The calculations showed that the Japanese earthquake sped up Earth's rotation by about 1.8 microseconds, which is about 1.8 millionths of a second. Not a big deal, but at the end of the day, every nanosecond counts. For comparison, the infamous Indonesian earthquake shortened the length of a day by 2.68 microseconds. It struck on December 26, 2004, at 0:58 UTC. The epicenter lay off the western coast of northern Sumatra, Indonesia. This powerful undersea earthquake triggered devastating tsunamis that swept across the Indian Ocean, causing widespread destruction and immense loss of life in countries like Indonesia, Sri Lanka, India, and Thailand. Even coastal areas as far as East Africa had severe damage. The Earth's magnitude, initially recorded at 9.0 on the Richter scale, was later adjusted to between 9.1 and 9.3, making it the most powerful earthquake ever recorded in Asia. The faulting, that's when Earth's crust completely breaks and its parts slide past each other, lasted between 500 and 600 seconds, and it was the longest duration ever observed. The immense force of the quake caused the entire planet to vibrate by at least half an inch and triggered other earthquakes as far away as Alaska. All that immense energy the earthquake released caused subtle but quite measurable changes to Earth. The shift in mass slightly changed the planet's rotation, shortening the day. It also caused a small wobble in Earth's axis from 1 to 2.4 inches toward 145 degree east longitude. So, when it comes to changes in Earth's rotation speed and axis, it's all about the redistribution of mass. This can happen naturally through disasters, but human activities can also trigger it. Take the Three Gorges Dam, for instance. This massive structure across the Yangtze River in China's Hubei province may seem to be an engineering triumph, but it's pretty ambiguous. Finished in 2012 after nearly 20 years, this massive dam is 7,660 feet long and 607 feet high. And yes, it is so big that it can affect the way our planet spins. Its reservoir is capable of holding 9.5 cubic miles of water, has enough mass to slightly alter the Earth's rotational inertia, slightly slowing the planet's rotation. According to NASA, the Three Gorges Dam reservoir could shift Earth's pole position by almost 1 inch and increase the length of a day by 0.06 microseconds. Dams aren't the only worry. If polar ice melts, water rushes into the oceans, hiking up sea levels, especially near the equator. This mass shift slows Earth's spin way more than dams do. You won't feel it day to day, but it can affect ultra-precise equipment, such as atomic clocks. To fix this, scientists suggested a negative leap second, making a minute 59 seconds, to balance Earth's spin changes. Okay, so you're thinking you've got nothing to do with all those tilts. You don't build dams, right? Bad news. If you take regular showers, you're part of it too. Every time you turn on the tap, you're affecting Earth's tilt just a tiny bit. Thing is, our planet is always shifting and adapting, so even small actions like using water can influence its orientation. Over the past 2 decades, groundwater pumping has caused the Earth's tilt to shift by 31.5 inches. This water redistribution is equal to about 0.24 inches of sea level rise. It turns out that among climate-related causes, groundwater redistribution has the largest impact on the drift of Earth's rotational pull. But what is groundwater? It's the water stored beneath the Earth's surface, filling the spaces in soil, sand, and rock. It comes from rain and other precipitation that seeps into the ground, collecting in underground reservoirs, aquifers. Unlike rivers and lakes, groundwater stays below the surface, acting like a natural water reserve. Thanks to it, we have a steady supply even during dry periods. Many people, especially in rural areas, rely on groundwater as their main source of drinking water. Farmers use it to irrigate crops, while industries depend on it for manufacturing and cooling systems. It sounds pretty harmless, doesn't it? How can something so useful cause our planet to shift? Well, a study covering data from 1993 to 2010 revealed that we've pumped about 2,150 gigatons of groundwater in that time. And this large-scale water removal has shifted the Earth's tilt and rotation. After we use groundwater, much of it eventually flows into the oceans, contributing to rising sea levels. In areas like Western North America and Northwestern India, people use a lot of groundwater, and it may have a connection to these shifts. Yikes, let's face it, all these findings are rather disturbing. But you know, understanding the impact of groundwater use is already a huge step in the right direction. Hey, I'm not done yet. This tilting issue isn't just about stuff happening on Earth. We also need to look at space. We've talked a lot about water, right? Well, you know that the moon has a big role in that. Its gravity is super important for forming tides and all that. So one more thing that affects our planet a lot is the gradual movement of the moon away from Earth. These two bodies interact gravitationally, which makes Earth's rotation slow over time, even though significant events like earthquakes occasionally speed it up temporarily. How did we figure it out? Glad you asked. Once, someone paid attention to ancient corals. After analyzing them, scientists realized that Earth had once rotated much faster. The thing is, corals grow by laying down thin layers of calcium carbonate. They do it daily, and variations reflect seasonal changes. By counting these layers, scientists have calculated the number of days in a year millions of years ago. They found that Earth had about 420 days per year 444 to 419 million years ago. But over time, the moon's influence had caused Earth's rotation to slow. And now we only have 365 days in a year. I feel robbed, you know? At the moment, the moon is moving 1.5 inches away from Earth each year. That's about the same speed at which your fingernails grow. Astronomers have figured it out with the help of special mirrors placed on the moon during the Apollo missions. For over 50 years, researchers have been sending laser beams to these mirrors and measuring the time it took for the light to bounce back. In any case, dear Earth, at the moment, your condition isn't critical. As for your inhabitants, they won't fall off your surface. All thanks to your gravity, pulling them toward your center. Just don't switch it off, and everything's gonna be fine.
The protective shield of our planet decays and eventually fails. So do our satellites. First, communication satellites in the highest orbits go down. Next, astronauts in low Earth orbit can no longer contact their mission control center. And finally, hazardous, relentless cosmic rays start bombarding everything on Earth, causing havoc and devastation. Are these the terrifying consequences of the planet's magnetic field reversal we're going to face? Right now, as you're watching this video, Earth's north magnetic pole is extremely out of whack. It's so serious that scientists will have to update the global magnetic field model released a mere 4 years ago. Does it all mean that the magnetic pole of our planet will flip soon? Well, be patient, we'll figure it out a bit later. You see, the magnetic pole is moving quite erratically from the Canadian Arctic towards Siberia, and these movements are very unpredictable. But it's normal for the pole to be moving. There are long-term records from London and Paris that prove that the North Magnetic Pole moves randomly around the rotational North Pole over periods of several hundred years. But the most astonishing thing about its movement is that it's speeding up. Around the mid-1990s, the magnetic pole unexpectedly accelerated from a bit over 9 miles to 34 miles a year. And recently, the pole crossed the international dateline, moving toward the eastern hemisphere. The European Space Agency launched extremely accurate magnetic field satellites in 2013. Thanks to them, researchers have superb data they can use not only to make magnetic field maps, but also to update them every 6 to 12 months. That's how they were able to notice that the core field was weakening too. It might be a sign that the planet's magnetic field is about to flip. To understand this process better, we need to figure out how the core field works. Let's say we've got a bar magnet that runs through the center of our planet and has a north and a south pole. This magnet is incredibly strong, representing about 75% of the intensity of our planet's magnetic field at the surface. Our bar magnet is not only moving, but is also getting weaker, by about 7% every century. Admittedly, this bar isn't the perfect representation of the core field. It's more like electric currents generating Earth's magnetic field. Still, this model makes it easier to see what's happening to our planet now. The magnetic field of our planet plays an important role in protecting us from dangerous radiation and geomagnetic activity, which is the product of the interaction between the solar wind and Earth's magnetosphere. Earth's magnetic field also moves. Scientists have been studying and tracking the movement of the magnetic poles for hundreds of years. The historical motions of these poles indicates changes in the global geometry of the magnetic field of our planet, and they may point to the beginning of the field reversal too. That's what the flip between the north and south magnetic poles is sometimes called. You see, if the north magnetic pole moves a bit, it isn't a big deal. But a complete reversal might have a serious impact on the climate of our planet, as well as modern technology. Luckily, such flips don't happen overnight. The entire process stretches over thousands of years. Plus, even though the magnetic pole weakens during a pole reversal, it doesn't disappear completely. So those scary events from the beginning of the video aren't likely to happen to us. The magnetosphere will continue protecting the planet from cosmic rays and charged solar particles, even though there might be some amount of particulate radiation that will make it to Earth's surface. Magnetic fields are generated by moving electric charges. If some material allows these charges to easily move in it, it's called a conductor. Metal is a great conductor, and we often use it to transfer electric currents from one place to another. In this case, the electric current is negative charges called electrons moving through the metal. The current is what generates a magnetic field. Earth has a liquid iron core. In other words, there are layers and layers of conducting material inside our planet. Currents of charges are constantly moving through the core, and the liquid metal is also moving and circulating there, generating the magnetic field. This magnetic field, in turn, produces something resembling a bubble around the planet. It's called the magnetosphere, and it's located above the uppermost part of the atmosphere. This layer shields and deflects high-energy cosmic radiation, which otherwise would be extremely dangerous to people and other forms of life on Earth. The magnetosphere also interacts with the ionosphere, the layer of our planet's atmosphere containing loads of ions and free electrons and capable of reflecting radio waves. The interaction between these two layers and the magnetized solar winds is what scientists call space weather. The solar wind is normally mild, and there's no space weather whatsoever. But sometimes, the sun starts shedding gargantuan magnetized clouds of gas that can accelerate to incredible speeds. They're called coronal mass ejections, or CMEs. They're ejected from the sun over the course of several hours. CMEs usually look like giant twisted ropes and can occur spontaneously. Their frequency varies according to the 11-year-long solar cycle. For example, at a solar minimum, you can observe one ejection per day, and when the sun is in its most active phase, there might be 3 CMAs per day. Coronal mass ejections disrupt the calm flow of the solar wind and cause serious disturbances that can damage stuff, both in space near Earth, like satellites, and on the planet's surface. If coronal mass ejections make it to Earth, their interaction with the magnetosphere generates geomagnetic storms. Those can trigger auroras, happening when a stream of energized particles hits the atmosphere and lights up. And then there are also solar flares. They develop more rapidly and with much more energy than coronal mass ejections. Solar flares often occur soon after coronal mass ejections. The most powerful volcanic eruptions pale in comparison to solar flares that release 10 million times more energy. Within a few minutes, one solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot, with temperatures reaching several million degrees Fahrenheit. Astronomers believe that such bursts of solar radiation happen when the sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. A powerful solar storm can potentially cause a devastating global blackout on Earth. If not for the Earth's magnetosphere, the effects of the sun's activity would be much more devastating. Luckily, the magnetosphere deflects most of the solar material hurtling towards our planet from our star at a speed of over 1 million miles per hour. But even so, during space weather events, there's a lot of hazardous radiation near Earth. It can potentially harm astronauts and spacecraft. Plus, space weather can damage large conducting systems, for example, pipelines and power grids, by overloading currents running inside them. Scientists regularly map and track the overall orientation and shape of our planet's magnetic field. To do it, they use local measurements of the field's orientation and magnitude. That's why they've been able to conclude that the location of the North Magnetic Pole has moved by almost 600 miles since the first measurements were taken in 1831. The magnetic field of our planet reverses on a timescale varying between 100,000 to 1 million years. One can tell how often it happens by looking at volcanic rocks at the bottom of the ocean. They capture the orientation and strength of Earth's magnetic field at the time of their creation. So, dating those rocks gives us a good picture of how our planet's magnetic field has evolved over time. From a geological point of view, field reversals happen quite fast, but they are extremely slow from a human perspective. A complete reversal normally takes a couple of thousand years, but during this time, the orientation of the magnetosphere may shift, exposing more of Earth to cosmic radiation. Such events tend to change the concentration of ozone in the atmosphere. In any case, scientists can't say for sure when the next field reversal will happen, but they keep mapping and tracking the movement of our planet's magnetic north. By the way, the Earth isn't the only planet with a magnetic field. Gas giants, like Jupiter, also have a conducting metallic hydrogen layer that generates their magnetic fields. Jupiter's internal magnetic field prevents the solar wind from interacting directly with the planet's atmosphere.
It's official. Official. A day will no longer last 24 hours. Earth's now spinning faster, literally, and our days are going to get shorter. At the moment, it's believed that the shortest day happened on July 10th, 2025. It was shorter not by much, just a fraction of a second, 1.36 milliseconds according to most sources, but still. And all because of the moon's position messing with Earth's rotation, just enough to speed things up. If it turns out to be not a one-time thing and Earth keeps spinning faster, it could be the start of a big mess. All our time stuff like GPS, the internet, atomic clocks, even how countries keep time, depends on the day being 24 hours. But if the planet speeds up, those systems could totally freak out. Clocks would get all out of whack, and anything that needs perfect timing could go sideways. We're talking about more than just a few lost seconds. This could shake up everything. Flights, money transfers, basically how we live day to day. We'll have to rethink how we measure time. Are you ready for that kind of chaos? Now, normally a day is 24 hours, or 86,400 seconds, because that's how long it takes for the planet to do a full spin. But Earth's rotation isn't always stable. A bunch of things influence it, like where the sun and the moon are or how the planet's mass is balanced. Earth is like a giant spinning top, and anything can throw it off rhythm. But our planet has been slowing down for a long, really long time. Because according to scientists, about 1 to 2 billion years ago, a day only lasted 19 hours. Not because the planet was lazy or anything. Nope, it was the moon's fault. It was way closer to us back then. Its gravity had a stronger pull, and that made Earth spin faster. And that faster spin meant shorter days. The thing is, the moon is slowly drifting away from Earth, and as it does, Earth's rotation slows down, and our days get longer over time. But during that billion-year window, something weird happened. The moon kinda just hovered at a certain distance. It wasn't moving out, it wasn't pulling harder. It was like it paused. And that pause locked us into 19-hour days for what scientists are now calling a boring billion. It was a time when pretty much everything on Earth slowed down. Tectonic activity was stable, the climate wasn't doing anything weird, and even life kind of plateaued. Now, let's get into the sciencey part. The moon's gravity controls our ocean tides. That's what slows down Earth's spin. But the sun pulls on Earth too, just in a different way. When sunlight hits Earth's surface and heats it up, that creates what's called solar atmospheric tides, and those can actually speed up Earth's rotation. Right now, the moon's gravitational tides are about twice as strong as the sun's atmospheric tides, which means the moon is in charge when it comes to Earth's spin. But back in the boring billion, the sun and moon were basically in a tug-of-war with equal strength. This phenomenon is called tidal resonance. It's like Earth hit a cosmic pause button. If the moon hadn't backed off, we might still be living in a 19-hour day world right now. These days, the moon is still drifting away from us, and because of that, our days are slowly getting longer. Until lately, things have gotten weird. In the last few years, scientists noticed that Earth hasn't been sticking to schedule. In fact, it's been spinning faster, and I mean record-breaking fast. Back in 2020, Earth started picking up the pace more than it had since scientists started clocking it in the 70s. Then came July 5th, 2024, the shortest day ever recorded. We lost 1.66 milliseconds. Not a big deal if you're just watching videos on YouTube, but on a planetary scale, it's kinda huge. Now, we get back to July 10th, 2025. On that date, the moon was sitting way up near the poles, very far from Earth's equator. And that changed the game. When the moon is hanging out closer to the poles, it messes with Earth's rotation and makes our days a little bit shorter. That kind of change isn't unusual. Earth's spin has always had some ups and downs. But today, the moon isn't the only factor. According to NASA, human activity is changing how Earth spins too. Between 2000 and 2018, moving ice and pumping groundwater around the planet shifted enough mass that it added 1.33 milliseconds to our days per century. natural disasters can mess things up too. Remember the massive earthquake that hit Japan in 2011? It actually shortened Earth's day by 1.8 microseconds. Just one quake, one microjolt to the planet's schedule, but the consequences were catastrophic. On March 11, 2011, at exactly 2:46 p.m. local time, a huge earthquake hit off Japan's east coast. We're talking magnitude 9, one of the biggest quakes ever recorded. The epicenter was about 80 miles from Sendai and over 230 miles from Tokyo. Japan's main island shifted 8 feet. Yes, the ground moved and whole cities literally slid. But it didn't just shake buildings and trigger a tsunami. The quake was so strong it redistributed Earth's mass, like shifting weights around on a spinning top. When you do that, the top spins differently. Same deal with Earth. The movement of tectonic plates was enough to tweak the whole planet's rotation. The thing is, the earthquake moved land and shifted Earth's figure axis. That's the axis our planet's mass balances around, by 6.5 inches. That's separate from the north-south spin axis, which we rotate on daily at about 1,000 miles per hour. But still, that shift was enough to make Earth wobble differently as it was spinning. It didn't tilt the entire axis in space. Only stuff like the sun or moon's gravity can do that. But it was still a major shakeup, no pun intended. And it wasn't the first time this had happened. The 2004 Sumatra quake, a staggering magnitude 9.1, sped up Earth's spin and cut 6.8 microseconds off the day. Chile's 2010 quake took off another 1.26 microseconds. Every time one of these mega quakes hit, it's like Earth gets a tiny jolt, spinning just a hair faster. And it might not be over. For example, that March 11 quake unleashed more than 80 aftershocks that were magnitude 6.0 or higher. Long after, some of those aftershocks were still tweaking the day length. It was very subtle, changes in millionths of a second, but real. But the thing is, even the seasons can mess with how fast Earth spins. A geophysicist from the University of Liverpool has explained it like this. There's way more land in the northern hemisphere than in the south. So, during northern summer, trees grow leaves, and that leaf mass moves upward, farther from Earth's center. And it sounds pretty harmless, right? But no, that tiny shift actually slows down our planet's spin, just a bit. Think about a figure skater arms in. They spin faster. Arms out, they slow down. Same with Earth. When its mass shifts away from the core, it rotates more slowly. So yeah, in the summer, Earth literally chills a bit, spin-wise. Now you don't panic about your day suddenly feeling longer yet. Your clock is still gonna say 24 hours. That's just how our timekeeping works. As for these differences, they're milliseconds. You'd never feel it. But the problem is that over time, it all adds up. If the planet ever spun slow enough that we were off by more than 0.9 seconds, then we'd have to do something. That's when the International Earth Rotation and Reference System Service steps in. These are the people who keep tabs on Earth's spin, and if things drift too far out of sync with our clocks, they throw in a leap second to fix it. Yep, they literally add a second to the clock every now and then to keep Earth time on track. It's like the universe's version of a software update. In any case, with the moon slowly drifting away and Earth calming down, the fact that our planet is suddenly picking up speed, even just a little, makes experts and ordinary people raise their eyebrows. It's a reminder that even something as basic as a day isn't set in stone. The planet's moving quicker. Time is literally slipping. Something's shifting. A long time ago, a huge meteorite smashed into the Earth with a horrible destructive power. It was several times bigger than the one that wiped out the dinosaurs 65 million years ago. Luckily, there were no lives it could have taken, or else it would have been a real catastrophe. Now, scientists think it did leave behind a huge footprint, the massive Antarctica impact crater that is bigger than the entire state of New York. The location also has a gravitational Wilkes Land anomaly going on. At first, scientists noticed something weird here when they measured Earth's gravity in that region. A strange gravity hole, or a negative gravity anomaly. Later, with better technology, they found something even weirder. There was a positive gravity anomaly inside that gravity hole, a spot with stronger gravity. This kind of structure, called a mascon, short for mass concentration, often shows up in places where giant
Before an earthquake shakes the ground, something sneaky might happen first. A slow, quiet movement with no shaking at all. No one is aware that right under their feet, the land is preparing to tremble violently, wreaking havoc, bringing destruction and devastation. A new study shows that such a slow creep might be how earthquakes begin. To figure this out, scientists didn't start with giant pieces of the Earth. Instead, they went into a lab and used clear plastic sheets called plexiglass. They pushed two sheets of plexiglass sideways against each other, just like how tectonic plates, huge chunks of Earth's crust, push against each other underground. As they pushed, the plastic cracked, kind of like what the Earth does during an earthquake. And even though it was plastic and not rock, the physics, the way things break and move, was the same. Earthquakes happen when two tectonic plates try to slide past each other, but they get stuck. The edges between them don't move easily because of something called friction. It's kind of like when your shoes grip the ground. Over time, the plates keep trying to move and stress builds up. Think of it like bending a stick. At first, it doesn't break, but if you keep pushing, it will eventually snap. The spot where the plates are stuck is called a fault, and there's a thin, brittle part in that fault. By brittle, I mean that it doesn't bend, it just breaks. Here's how it happens. First, a tiny crack forms. It's small and moves slowly. There's no shaking yet, but something is already happening under the surface. The crack spreads, building up more energy. When it finally reaches the edge of the brittle zone, boom! It speeds up, suddenly racing forward really fast, almost as fast as sound. And that's when the Earth starts to shake. So scientists decided to find out how that very first crack starts. They conducted their experiment, whose setup was similar to a type of fault in the real world called a strike-slip fault, like the San Andreas Fault in California. Even though the materials, plastic versus rock, are different, the way cracks form and move is exactly the same. The experiment has helped scientists understand that earthquakes don't always start suddenly. Sometimes there's a slow, quiet start, like a warning sign before the big quake. This early stage of an earthquake is called a nucleation front. It's like a seed of a crack, gently creeping through the material long before any actual rupture happens. This quiet and slow movement doesn't release energy into the surroundings. At first, scientists thought of cracks as simple one-dimensional lines, like a straight tear in paper. But something didn't add up. The slow-moving nucleation front wasn't behaving like a normal, fast-moving crack, and it wasn't clear why or how it suddenly sped up and became an earthquake. The answer came when scientists realized they had to think in two dimensions instead of one. Instead of imagining the crack as just a fine line, they began to think of it as a patch, like a growing circle, that starts at the surface where two materials touch. As this patch spreads out, more material along its edge has to break. The important thing here is that the energy needed to break the material is related to how long the patch's edge or perimeter becomes. The bigger the perimeter, the more energy it takes to keep breaking. That's why this patch moves slowly at first. It doesn't yet cause the violent shaking we associate with an earthquake. Because it moves without sending shaking waves, this stage is called aseismic. Eventually, the growing cracked patch spreads beyond the special brittle zone, where the materials are stuck. Outside this zone, the energy needed to keep breaking the material doesn't increase anymore. Instead, there's now extra energy building up, more than what's needed to keep the crack growing slowly. This extra energy doesn't stay quiet. It suddenly powers the crack to move much faster, turning it into a full-speed rupture. That's the moment when the earthquake begins and the ground starts to shake. These findings help explain how earthquakes might start off slow and silent before quickly turning dangerous. They show that small, slow cracks can suddenly transform into powerful, fast-moving ruptures if the conditions are right. Scientists believe that they can learn to detect the aseismic stage before a crack speeds up. It might one day be possible to predict earthquakes, or at least understand the warning signs better. Now, even though earthquakes are only the third most common type of natural disaster, they cause the highest number of fatalities. NASA plays an important role in studying earthquakes by using satellites that orbit the Earth. These satellites collect data and images that show how the ground changes after an earthquake. For example, they can detect when the land shifts, rises, sinks, or cracks. These surface changes help scientists learn more about the strength and impact of earthquakes. NASA's satellites can also track changes in nighttime lights. If a city goes dark after a quake, that's a clear sign that the area may have lost power and could need help. Now, how about we talk about the most common earthquake myths, like the one about megaquakes? Some people really worry about super huge earthquakes, but there's a limit to how big they can get. The size of an earthquake depends on the size of the fault where it happens. A longer and deeper fault can cause a bigger earthquake. For example, the San Andreas Fault in California is long, about 800 miles, but not very deep, around 10 to 12 miles. This makes earthquakes bigger than magnitude 8.3 on that fault very unlikely. The biggest earthquake ever recorded happened in Chile in 1960. It had a magnitude of 9.5 and occurred on a huge fault that was almost 1,000 miles long and 150 miles wide. Technically, there's no set limit on the magnitude scale, but an earthquake bigger than magnitude 12 would need a fault larger than Earth, which just isn't possible. Now, earthquakes can happen near the surface or deep underground. Most occur in Earth's crust or upper mantle, down to about 500 miles deep. But the deepest ones happen only at subduction zones, places where one part of Earth's crust slides under another. In California, almost all earthquakes happen in the top 15 miles of the crust. One exception is the Cascadia subduction zone in Northern California, which continues up through Oregon, Washington, and Canada. Another misconception is that the ground can open during an earthquake, but usually that only happens in movies. A giant crack opening and swallowing things up during an earthquake is just fiction. In real life, the ground on either side of a fault slides past each other. It doesn't pull apart or open wide. Small cracks or holes can happen during landslides or ground failures, but not along the actual fault line itself. Faults don't open up because if they did, there'd be no friction, and without friction, there wouldn't be an earthquake at all. Now, some people think California could break off and sink into the ocean during an earthquake, but that's not how it happens. The ocean floor is just lower land with water above it. California can't fall in. What's really happening is that southwestern California is slowly sliding north toward Alaska along the San Andreas Fault. The Pacific Plate, which California sits on, is moving about 2 inches per year, about as fast as your fingernails grow. So, in about 15 million years, Los Angeles and San Francisco could be neighbors, and in 70 million years, Los Angeles might be sitting near Alaska. I can't wait. People often wonder whether an aftershock can be bigger than the earthquake itself. Aftershocks are smaller earthquakes that happen in the same area after a larger one. They're like our planet's way of settling down after the main shock. But if an aftershock turns out to be bigger than the first earthquake, then we call the bigger one the main shock, and the earlier one becomes a foreshock. About 5 to 10% of earthquakes in California are followed by a stronger one within a week. It's also possible for 2 quakes in the same area to be about the same size. However, very large earthquakes are rare, so it's even rarer to see 2 huge ones happen close together. The Earth. Frozen and alone, exiled into deep space. Jupiter, the only remaining planet orbiting the Sun. No, it's not a premise for a disaster movie. It's one of many real scenarios scientists explored in their latest simulations. This time, the threat isn't the Sun swelling or a giant asteroid knocking planets into it like a cosmic bowling ball. It's something quieter and possibly already on its way. A recent study examined the potential consequences of a passing star coming too close. One such flyby could send planets crashing, flinging them into space, or mess with their orbits just enough to cause climate changes. But what are passing stars, and how likely is that to occur? Passing stars are normal stars, like our Sun, that move around the Milky Way. Since everything in space is always moving, sometimes stars pass near each other. Usually it's not a big deal. But if a star gets really close, its gravity can tug on planets like Neptune. That tiny tug can slowly change how the planets move, like a ripple spreading through the whole system. Scientists study these close encounters because, even though they don't happen often, they can have big effects over millions of years. They help us understand shifts in planetary orbits and how they may have shaped Earth's past. In fact, one theory suggests that a flyby 56 million years ago is what caused great climate change when Earth's temperature rose by up to 14 degrees Fahrenheit in just a few 100,000 years. That huge temperature jump changed life on Earth, leading to the evolution of some species while causing others to disappear. Even though it's impossible to prove whether there was a flyby a long time ago, we do know that events like this could mess with Earth's orbit in the long run. That's in the past, but what about the future? So far, we know that the solar system will have a close encounter with another star called Gliese 710 in about 1.3 million years. Gliese is moving towards us and is projected to pass within 10,000 astronomical units of the Sun. It won't come close enough to throw planets off, but it could still send icy comets from the Oort cloud our way, like a bored kid tossing a snowball without looking. One might hit something, but probably won't. However, in a recent study, scientists wanted to explore a more extreme scenario. What if a star passed even closer, say just 100 astronomical units from the Sun? That's about 100 times the distance from Earth to the Sun. From our point of view, it's almost unimaginably far, but in space, it's practically brushing shoulders. They ran thousands of long-term simulations covering up to 5 billion years of our solar system's future, and it turns out it doesn't take much. Just one close encounter can be enough to disturb the outer planets, like Neptune, and set off a slow-motion chain reaction that ripples inward. Over time, that gentle nudge can throw the whole system into chaos, a true cosmic butterfly effect. The good news is that even in this worst-case scenario, in 95% of simulations, the passage is nothing to worry about, and all the planets remain in place. However, in the remaining 5%, well, it's one disaster after another. The most frequent casualty in these simulations was Mercury. In nearly half of all unstable scenarios, Mercury ends up on a doomed path straight into the Sun. It's the smallest planet and the closest to our star, so it's especially susceptible to gravitational nudges, whether from the gas giants or from a disturbance rippling inward from a stellar flyby. When Mercury spirals into the Sun, you might think it's game over for the rest of the planets, but that's not always the case. Sometimes the system absorbs the loss and restabilizes, like an orchestra that keeps playing even after one violinist falls off the stage. Oops. Funny enough, Mercury already has a chaotic orbit, the most stretched and tilted of all major planets, and some studies already consider its fall into the Sun in the distant future inevitable. Now, Venus has a slightly better chance in these chaotic scenarios. It doesn't get ejected or swallowed by the Sun as often as Mercury, but it's far from being safe. Most of the time, the instability happens after Mercury goes rogue and disrupts Venus's orbit, nudging it into a slow-motion crash course with Earth or Mars. Even without the interference from field stars, long-term simulations show a tiny but real chance that Venus could eventually collide with Earth just from the way Jupiter affects Mercury. A Venus-Earth collision would result in both planets being completely destroyed. Oh well. A similar fate awaits Mars. According to simulations, in about 0.3% of cases, It either gets flung out of the solar system or collides with another planet. Mars is smaller and lighter than Earth, with weaker gravity, which makes it easier to knock it off track. What's interesting is that even in some cases where Mars is lost, Earth often manages to stay in place. Jupiter happens to be the heavyweight champion of the solar system, the proud owner of its own cloudy belts. Thanks to its massive size and strong gravity, it acts like an anchor, keeping everything else in check. There are 392 scenarios out of 12,000 simulations where all but one planet vanished, with Jupiter being the last one standing. Its stabilizing influence helps prevent smaller planets from going off course, and in some cases, it even helps the system recover after a disruption. Saturn, while less massive, seems to be Jupiter's loyal partner. But models show that when Saturn shifts its orbit abruptly, it can send gravitational ripples, known as secular resonances, straight into the inner solar system, nudging the orbits of planets like Earth and Mars. Finally, the most vulnerable ones are Uranus and Neptune. Sitting at the edge of the solar system, they're the easiest to knock loose, and in many simulations, they get ejected entirely. That loss sends gravitational ripples inward, disturbing the rest of the planets over millions of years. Even a tiny shift by 0.1% in Neptune's orbital distance can throw the whole solar system out of sync. The balance of gravitational forces would shift, forcing Jupiter and Saturn to readjust, which would push the disturbance toward the inner planets, destabilizing everything. Which brings us to the big question: what about Earth? While most simulated models leave Earth untouched, about 0.2% of the simulations end with Earth either colliding with another planet, Venus, or being thrown into the Sun. Out of 12,000 simulations, in 23 of those, Earth ends up as the only one still orbiting. But that's only if we don't include the Moon in calculations. With the Moon included, Earth becomes harder to predict. Our satellite could crash into Earth, get ripped away by a passing star, or destabilize our orbit over millions of years. Once again, this is a worst-case scenario, and while the odds are really, really small, it's not impossible. So, with that in mind, let's entertain the idea and see what would happen to Earth if it were to end up exiled from the solar system. Earth would become what scientists call a rogue planet, drifting through interstellar space with no sun to anchor it. The surface would quickly freeze, with temperatures dropping to hundreds of degrees below zero. But surprisingly, life wouldn't vanish completely. Earth's core would stay hot for billions of years, powered by radioactive decay and leftover heat from its formation. That heat could keep underground pockets warm. Scientists believe that this is the case with icy moons like Europa or Enceladus. Life might cling on in different caves or buried oceans. It wouldn't be a thriving world, but it wouldn't be completely empty either, at least for a while. Just cold, quiet, and alone. A ghost of a once lively world. And somewhere out there, maybe another civilization will look up, spot a faint blue dot drifting by, and curiously start running simulations of what might happen if this blue planet were to get really close, say just 100 AU from their sun.
Roofs fly off like paper, huge trees are yanked from the ground, power lines snap and leave neighborhoods in the dark. Streets flood like rivers, homes are left in ruins. That's a hurricane passing through. After the wind calms down, the real mess begins. People stranded, no clean water, destroyed roads. Storms have been picking up for like 5,700 years. And the scariest part is that in the last 20 years, there's been a huge spike. But let's start from the very beginning. This is Belize, a small country on the northeastern coast of Central America. And this is the Great Blue Hole, a huge, deep underwater sinkhole about 410 feet deep and approximately 50 miles off the coast of Belize. It formed around 10,000 years ago, when the sea levels rose after the last ice age. A team of scientists arrived in Central America to study mud from way down in the Great Blue. They pulled out a long sample of sediment, which is basically layers of stuff that's settled over time. You might ask, so what? How are tropical storms connected with this sediment? Let's see. Tropical cyclones are big, spinning storms that form over warm ocean water. They pull up heat from the sea and blast it into the sky. And yeah, they can be devastatingly destructive, with super strong winds, heavy rain, and floods from big waves. And mud cores like the one the researchers pulled up are actually records of tropical storms. The sample they pulled up was 98 feet long, which made it the longest ever found in that area. Here's how it works. Every year, 2 thin layers of sediment settle in the hole where the weather is calm. But when a big storm hits, it leaves behind a different, messier layer. So by looking at these layers, scientists could tell how many storms hit that spot over the last 5,700 years. It's like counting tree rings, you know? Anyway, what they found was rather unexpected. It turns out that tropical cyclones had been getting more and more common. The lead researcher said that over the past 6,000 years, there were usually between 4 and 16 tropical storms or hurricanes every 100 years. But just in the last 20 years alone, they found signs of 9 storms in that same little area. That's way more than usual, and it shows how much things are changing. Scientists think there are 2 main reasons why tropical storms have been happening more often. One reason has to do with something called the Intertropical Convergence Zone, or ITCZ. This is an area near the equator where winds from the north and south come together. That spot has low air pressure, lots of moisture, and tons of thunderstorms. Just above it is the part of the Atlantic Ocean where most hurricanes are born. It even has an official name, the Hurricane Main Development Region. Normally, the ITCZ moves north in the summer and south in the winter because of changes in ocean temperatures. But over the past few thousand years, it's slowly been shifting farther and farther south. That's why the area where storms usually start has also moved south. It means storms are now forming and heading toward lower parts of the Atlantic than they used to. The second reason for the recent spike in storms is rising ocean temperatures. Earth has gotten warmer, and the ocean has warmed up too. The warm oceans help make more powerful storms. Such an increase likely means that this part of the world might see a lot more big storms in the future. If things keep going the way they are, scientists think the Caribbean could get hit by as many as 45 tropical storms and hurricanes by the end of this century. That's way more than anything the world has experienced in the last 5,700 years. There are just too many changes in the world that influence the situation. They create the perfect conditions for more storms to form and get really intense really fast. But if you think storms are getting more intense only over the ocean, let me tell you about America. A bunch of really dangerous storms, including tornadoes, dust storms, and wildfires, tore through several states in the Midwest and south of the USA in March 2025. At least 42 people lost their lives, and the scale of the devastation is enormous. What's scary is that most of this destruction didn't happen in the usual Tornado Alley area. Tornado Alley is a nickname for a part of the US where tornadoes happen a lot. It stretches through places like northern Texas, Oklahoma, Kansas, Missouri, parts of Louisiana, Iowa, Nebraska, and even eastern Colorado. But this time, storms hit places like Mississippi, Arkansas, and Alabama. Experts had warned this might happen. At the beginning of 2025, they said that tornadoes could start showing up more often farther east than usual, and that's exactly what's happening. One of their top weather experts said people in the Mississippi and Tennessee valleys should get ready for a rough spring. There are more people living in these areas than in traditional tornado zones, and many of them live in mobile homes or buildings without basements, which puts them at more risk when big storms hit. A tornado is basically a spinning tube of super strong wind that comes down from storm clouds and touches the ground. They can be really dangerous. To figure out how strong a tornado is, scientists use something called the Enhanced Fujita Scale. It goes from EF0, which stands for the weakest tornado, to EF5. Such a tornado is crazy strong, tear your house apart strong. The main question is, why are tornadoes happening more in the east now? In the US, tornado season usually kicks off in March. That's when cold air from Canada bumps into warm, wet air coming up from the Gulf of Mexico. And boom, storms start to form. But this year, things are a bit different. Here's what's going on. There's a big patch of high pressure, basically a chunk of calm, warm air hanging over the southwest. That's keeping things more stable out west, so fewer thunderstorms as well as fewer tornadoes are expected there. So, tornadoes are shifting eastward. Meanwhile, the Gulf of Mexico is super warm this year, and that's helping storms form in the southeastern US. The warm water adds a lot of energy to the atmosphere, which can lead to stronger, more frequent storms in places like Mississippi, Alabama, and Tennessee. Up north, around the Great Lakes and Northeast, it's staying cooler this spring. That means fewer big storms up there, at least for now. Now, let's get back to those devastating March storms. On March 14 and 15, a huge storm system blasted through parts of the central and southern US. This system brought 52 confirmed tornadoes, massive dust storms, and fast-moving wildfires. It all led to almost 1,100 canceled flights. About 150 million people were affected by this natural disaster. Two really strong tornadoes classified as EF4s hit Arkansas. The damage was incredible. One of those tornadoes, which hit a town called Diaz, had winds up to 190 miles per hour. That's insanely fast! For comparison, the average speed of a Formula One car is around 130 to 160 miles per hour. It was the first time in over 25 years that Arkansas got hit by two EF4s on the same day. Experts also recorded wind gusts moving at a speed of over 80 miles per hour in the southern plains. In Texas, dust storms led to fatal car crashes. Wildfires, caused and driven by the strong winds, burned through parts of Texas and Oklahoma. Oklahoma alone had more than 130 fires. So, what's next? Experts think the US could see between 1,300 and 1,450 tornadoes in 2025. That's way more than the usual 1,225. And it's not just about tornadoes. A warmer atmosphere can hold more moisture. That means heavier rains, more flash floods, and even more powerful storms. Basically, the formula is the following. Warmer oceans plus warmer air equals stormy weather, especially in the east and southeast. But even if you don't live in any of these areas, you can't feel completely at ease either. Experts say tornadoes and other natural disasters can happen pretty much anywhere in the US. The risk moves around depending on the time of year and the weather.
There is a powerful force hiding underground where tectonic plates meet, and one forces another under it. This happens in the Pacific and Indian Oceans. Strain builds over centuries. The tension is unbearable until the Megathrust awakens. The Earth shakes with a magnitude that can exceed 9 points, more powerful than any other earthquake. When the seafloor suddenly gets pushed up fast, it sends a huge ripple across the water, and a tsunami of huge force is out. These waves are called teletsunamis, and they cross entire ocean basins, ready to take over coastlines thousands of miles away. The thrust fault stretches over 600 miles. The Earth is not just shaking, it feels like it's tearing apart. This is the power of a megathrust earthquake. Those caught in its path will have to fight for their lives. Japanese authorities recently had to issue their first ever megaquake advisory. It happened because of a strong tremor on the edge of the Nankai Trough ocean floor zone. In the end, most of the warnings were lifted, and there wasn't much damage from the 7.1 magnitude earthquake. Parts of southwestern Japan started to shake, and the superfast trains in Japan slowed down to stay safe, which made travel slower for everyone. But everyone is staying alert as they know about the risk of a Megathrust earthquake that could happen within the next few decades in the Nankai Trough. The tectonic plate under the Philippine Sea is slowly sliding underneath the land where Japan is, moving just a few inches every year. The last big earthquakes from this area happened in 1944 and 1946, both with a magnitude of 8.1. These quakes have caused a lot of destruction in the country. The next Megathrust earthquake in the region, if it does happen, could be between a magnitude 8 and 9. Scientists still can't agree on how likely this mega earthquake is to happen, but it could be up to 80% certainty. On the other side of the Pacific, scientists from the U.S. Geological Survey have studied a dangerous area along the U.S. West Coast. It's called the Cascadia Subduction Zone, and it stretches from northern California to northern Vancouver Island in Canada. Over the past 14,200 years, there have likely been at least 30 big earthquakes in this region. One major quake happens every 500 years on average. But for a long time now, Cascadia has been quiet, and it worries scientists. They think this might be because the area is locked, meaning the tectonic plates are stuck together and building up a lot of pressure. Eventually, the part of the seafloor could suddenly break and move by several feet. The shaking would be just 5 minutes, but it would create a powerful tsunami as the seafloor shifts that would last for 10 hours. If it happens, it's going to be the worst natural disaster in the country's history, according to experts. The ground on some inland hills could turn into something like quicksand. This would cause the hillsides to slide and crumble, taking down roads and bridges. Around 620,000 buildings could be badly damaged or even collapse, including about 100 hospitals and 2,000 schools. People in Washington state might have to take care of themselves without help for 2 weeks, finding food, water, and shelter on their own. Scientists are studying slow slip events, where the tectonic plates move very slowly over weeks or months, releasing some energy but not enough to stop a big one. Every time the magnitude of an earthquake goes up by just one number, the energy it releases is 40 times bigger. So we'd need about 1 million small earthquakes every day for 500 years straight to release the same energy as one huge magnitude 9 earthquake. But these small earthquakes might be clues that a bigger earthquake is coming. To better monitor the Cascadia Fault, experts are mapping the fault more accurately and adding better monitoring tools offshore. Scientists receive over $10 million to install seismic sensors and seafloor pressure gauges on a fiber optic cable off the coast of Oregon. The goal is to be ready to warn people and potentially save lives when a big earthquake strikes. A sharp megathrust earthquake happened in this part of the world in 1964. It went down in history as the Great Alaska Earthquake and had a magnitude of 9.2. It lasted for more than 4 minutes, making it the most powerful earthquake in the history of the U.S. and North America. The ground shook so hard that it caused huge cracks and landslides. In Anchorage, many houses, buildings, and roads were destroyed because they weren't built to handle such a big earthquake. In some places, the land was permanently changed. For example, the coastline near Kodiak and Hinchinbrook Island was lifted by 30 feet. In other areas, like Gerwood and Portage, the ground sank by 8 feet. They had to rebuild roads higher so they wouldn't be flooded by the time. A huge 27-foot tsunami wiped out the entire village of Chiniga. Many coastal towns were heavily damaged, not just by the earthquake, but also by tsunamis and the fires that followed. After the main earthquake, there were thousands of smaller aftershocks for months. A moderate earthquake of magnitude 4.4 shook Los Angeles in August 2024. Once it was over, the LA Fire Department checked around the city and didn't find any major damage or anyone hurt. In the nearby city of Pasadena, which is close to the earthquake's epicenter, a water pipe burst inside City Hall and everyone had to leave the building. Thankfully, there was no danger of a tsunami. The best we can do to avoid panic in such situations is to be prepared. Japan is one of the places on Earth where earthquakes happen the most because it sits on the edges of 4 tectonic plates. Around 1,500 of these earthquakes each year are noticeable. Because of this, the people in Japan have learned to live with earthquakes. The 1950 law set a rule that buildings should be able to handle earthquakes up to a magnitude 7 without falling apart. An update 30 years later said that buildings should only have minor damage in such earthquakes and still work as usual. But if an earthquake is even stronger, the law says the building's main job is to not collapse and save people's lives. At the most basic level, buildings are made stronger with thicker beams, pillars, and walls so they can handle shaking better. Another technique is placing special pads made from materials like rubber at the base of a building. Some buildings are even built on thick layers of padding that separate them from the ground completely, which helps protect them during an earthquake. A skyscraper might sway back and forth a lot, moving up to 5 feet. To stop it from getting damaged, engineers can add something called dampers every second floor all the way to the top. These dampers are like giant bicycle pumps, but instead of air, they're filled with liquid. When the building shakes, the dampers push against the liquid inside them. Even though the liquid doesn't squish very much, it can still absorb some of the shaking. When they're building tall skyscrapers, engineers try to make the structure as simple and balanced as possible. This means having each floor the same height and placing the support columns evenly. But sometimes, architects who design skyscrapers don't want to make these compromises because they have creative ideas for how the building should look. Then they have to find compromise solutions. For example, Tokyo's Skytree Tower, one of the tallest buildings in the world, is designed in a futuristic style but also includes special features to protect it from earthquakes. It has a central pillar, like in traditional Japanese pagodas, and seismic dampers that help absorb the energy from an earthquake, keeping the building safe.
For hundreds of years, people in the US have reported hearing strange, loud booms. These mysterious sounds are called skyquakes. And yep, it's a real thing. If you've ever heard a loud, distant booming noise that definitely wasn't a thunderstorm or a car engine backfire, congrats, it looks like you've experienced a skyquake yourself. People report them all around the globe, from the US to India and Japan. They go under different names, and we still don't know why exactly they happen. Sometimes these booms come together with earthquakes. People heard them during the New Madrid earthquakes in the early 19th century and up until January 2020. Those who've experienced them describe skyquakes as a rushing or rolling noise. Famous American writer James Fenimore Cooper described it more poetically as the lake speaking to the surrounding hills, which send back the echoes of its voice in accurate reply. Sometimes these mysterious booms happen in cold weather instead of during earthquakes. One of the skyquake hotspots is near Lake Seneca in New York. They call them the Seneca Guns. The booms can be so loud that they shake windows and doors. Back in August 1886, after an earthquake in Charleston, people heard these noises for several weeks, happening at the same time as many aftershocks from the earthquake. In 2020, scientists from the University of North Carolina looked at old news pieces, especially from North Carolina, where people have often reported these sounds. They hoped to match the noises with earthquakes data, but they didn't find any link between the sounds and earthquakes. One of the researchers said they believe the noises are happening in the air, not underground. The team looked at infrasounds, which are low-frequency noises that humans can't hear. They found signals lasting 1 to 10 seconds that matched the times when people reported hearing the booms, but nothing is certain here. Some people think that solar flares, underwater tsunamis, or caves collapsing under the sea cause skyquakes. Others believe the sounds come from planes making loud sonic booms. But that doesn't explain old records of skyquakes from the past before planes were even invented. Some scientists think a type of meteor called a bolide causes these booms. These meteors blow up when they hit Earth's atmosphere. If this happened above thick clouds, the sound would get louder and travel far. but we wouldn't find anything on the ground. Another idea is that gas might be escaping from the bottom of deep lakes, like Lake Seneca. If you think skyquakes are bizarre, let me introduce you to fog bows. They also go under the name of white rainbows, ghost rainbows, or cloud bows. They form in a similar way to regular colorful rainbows, but are much wider. Rainbows happen when there are big raindrops in the sky, and you can always spot them on the opposite side of where the sun is shining. Fog bows are made by tiny droplets in fog, or clouds, instead of big raindrops, and they also appear opposite the sun. If you want to see a fog bow, you need to look for it in a thin fog when the sun is bright. You might catch one when the sun starts to shine through the fog, or if you're near the ocean where fog often forms. Because the water droplets in fog are so tiny, fog bows don't have bright colors like rainbows. They might even look all white, or just have faint colors. Some fog bows are hard to see at first, because they blend into the mist. But once you spot them, they're easy to recognize. The next rare weather phenomenon you gotta watch out for is thunder snow. You guessed it right. It's a special type of thunderstorm that happens during a snowstorm. Unlike regular thunderstorms that often strike in the spring and summer, thunder snow is much rarer because it happens in the strongest winter storms, like big blizzards, and at the same time needs warm air, which isn't a frequent combo. So, for thunder snow to happen, there needs to be moisture in the air, some instability, and something to lift the air like rising winds. Just like in normal thunderstorms, lightning can appear when you hear thunder. Thunder snow lightning usually goes from cloud to cloud instead of hitting the ground, and the thunder sounds different too, more like a low rumble instead of a loud boom, because the snow muffles the sound. You aren't so likely to get struck by it, but it's still important to stay inside when you hear thunder to stay safe. Northern Lights fans, this one is for you. Scientists noticed a new kind of glow in the sky that looked like a purple streak. They nicknamed it Steve as a joke, but later gave it a more scientific name: Strong Thermal Emission Velocity Enhancement, Steve for short. Steve is actually a fast-moving stream of super hot gas that always moves west and only shows up before midnight. They wondered if something like Steve could happen after midnight, but moving in the opposite direction. And now, scientists think they found the anti-Steve by looking at data from a research station in Norway. In December 2021, they took a picture of a bright purple streak stretching for 620 miles in the sky, and it only appeared after midnight. Satellites from the European Space Agency also measured the conditions in this part of the sky and found that the ions were moving eastward. Steve's late-night twin hasn't been officially named yet, but it would be cool if it was called SAM, which is short for Steve After Midnight. If you've ever seen snow on a sunny day when falling from the sky without a single cloud, it must have been diamond dust. It's a special kind of weather with millions of tiny ice crystals forming close to the ground. These ice crystals float slowly in the air, kind of like how dust floats in your house. When sunlight hits these crystals, they sparkle like diamonds. Unlike regular snow, diamond dust can fall from a cloudless sky, which is why they sometimes call it clear sky precipitation. It happens because of temperature inversion. Normally, it gets colder as you go higher up from the ground. But in a temperature inversion, the cold air stays near the ground, and warmer air sits above it. The warm air has more water vapor, and when it mixes with cold air near the ground, it turns directly into ice crystals, and diamond dust is born. For this to happen, the air near the ground has to be really, really cold, way below freezing temperature. Diamond dust can fall for days, but it's so light that it usually doesn't pile up on the ground like regular snow. A fall streak hole, also known as a hole punch cloud, is next on our list. This big circular or oval-shaped gap sometimes appears in certain clouds. These types of clouds float high up in the sky and are often made of tiny water droplets that are colder than freezing, but they haven't frozen yet. These special water droplets are called supercooled, and they need a reason to freeze. Ice crystals give them that reason. When a plane flies through the cloud, it can bring those ice crystals into the cloud. Once the ice crystals are there, the supercooled water droplets freeze quickly, get bigger, and start to fall from the ground. This creates a hole in the cloud, and as more nearby droplets freeze, the hole gets bigger and spreads outward. Any tornado is scary, but a fire tornado takes the horror to a new level. These bad boys are spinning towers of flame and ash that form when there's extreme heat, strong winds, and uneven ground. The intense heat from the fire causes hot air to rise quickly. Cooler air from the sides rushes in to replace it and creates strong winds. When winds from different directions meet, it makes the fire spin like a tornado. It gets stronger and can even create its own weather. It pulls in flames, ash, dirt, and anything in its path. The winds can reach speeds of over 140 miles per hour, and these fire tornadoes can last for more than 20 minutes.
The strongest earthquake ever to strike east of the Mississippi River that happened over 200 years ago was never over, according to some scientists. Most earthquakes last seconds to minutes, and the official record breaker so far is a silent one in Sumatra that was going on for 32 years. This slow slip event triggered a massive quake and a tsunami. So if it's true that the new Madrid earthquake is still sending aftershocks, we'll have a new top name for this sad list. The earthquake started in December of 1811 with a powerful quake in a sparsely populated part of northeast Arkansas. They felt the shaking almost 1,000 miles away in the White House, and the tower bells were ringing in Boston, even further away. It even made the mighty Mississippi flow backward for a few minutes over new waterfalls formed by shifted ground. The town of New Madrid, Missouri, completely disappeared in the disaster. The Earth wouldn't stay still until the end of January the following year, when things got serious again. A massive quake hit, this time near the junction of the Ohio and Mississippi rivers, right in the Missouri boot heel. Geologists believe it was a rupture on the New Madrid Fault, putting even more strain on the nearby Reelfoot Fault. Just when people thought it couldn't get worse, another 2 weeks of trembling passed, and the Reelfoot Fault snapped deep beneath New Madrid. Down in Tennessee, about 15 miles south of New Madrid, the ground uplift created Reelfoot Lake. Steamboats were chugging along the river, with thousands of trees floating and acres of woods torn apart by the quake. In St. Louis, Missouri, which is 160 miles away, buildings were badly damaged, and chimneys fell in Cincinnati, Ohio, 400 miles away. People all the way in Montreal, Canada, over 1,000 miles away, felt the earthshake. Seismologists have registered about 200 small earthquakes in the New Madrid seismic zone every year since 1974. Some researchers believe that up to 30% of those were aftershocks from those big quakes back in 1811 and 1812. In parts of the U.S. where there's not much tectonic action going on, these aftershocks could keep rumbling for years, maybe even centuries, after the big ones hit. Aftershocks are the Earth's way of releasing all that built-up stress from the main quake. When the ground shakes from the first earthquake, it puts a lot of pressure on the rocks nearby. And when those rocks can't take it anymore, they crack, causing even more shaking. That's the aftershock. And they can be pretty intense, especially right after the main quake, but weaken over time. Not all scientists agree that contemporary earthquakes have to do with those from 200 years ago. We mostly associate faults with those lines where Earth's plates meet. But there's a whole network of those right under the center of the North American plate. They're like relics from 750 million years ago, when North America was part of a supercontinent called Rodinia. When Rodinia started to break up, it left behind these rifts, weak spots in the Earth's crust that run deep beneath the modern Midwest. It could explain the earthquake action. An international team of geologists decided to take a fresh look at 3 major earthquakes that shook North America and end the debate. They used a new math method called the nearest neighbor. It says that if earthquakes are too close in space, time, and magnitude to be independent background events, then one is assumed to have triggered the other. Depending on how you look at the numbers, somewhere between 10 to 65% of the recent quakes in the region could be aftershocks of those historic earthquakes. And a huge quake that hit Charleston, South Carolina at the end of the 19th century might explain up to 72% of the earthquakes in the area since then. But not all places are the same, so the scientific debate continues. In 1774, British explorer James Cook noticed a glow in the distance. It was the volcano of Mount Yasur in Vanuatu. This bad boy had been spewing lava and ash ever since, and it's quite likely that it's been doing that for way longer. The volcano has been sitting at alert level since October 2016, which means things are really unsettled around there. They've even marked off a 2,000-foot radius around the crater to keep people safe. There have been low to moderate outbursts, shooting out ash, gas, and steam, and some bigger blasts throwing stuff outside the crater. Satellite images have picked up on some hotspots of sulfur dioxide plumes, showing that Yasur is still cooking up a big storm down there. Stromboli, one of the volcanic islands near Sicily, officially has the Guinness World Record as the longest continuously erupting volcano. It has been putting on a fiery show for over 2,400 years straight. Ancient sailors nicknamed it the Lighthouse of the Mediterranean. Most of the time, Stromboli's just spitting out spatter, but every now and then it throws in some lava flows or shoots up some moderately high fountains. Sometimes you might even catch a glimpse of steam-driven outbursts. Over 200 million years ago, the world went through a major makeover, with not one, not two, but 4 massive volcanic eruptions changing the game. It all happened in Rensselaer, a large chunk of island that used to be a supermassive volcano stretching across what's now British Columbia and Alaska. This volcanic activity might have helped dinosaurs grow from cat-sized critters into giants we saw in Jurassic Park. It kicked off a 2-million-year rainy season. It made the whole world hot and humid, and the dinos just loved it. Researchers dug deep into sediment layers beneath an ancient lake in China to uncover these secrets. They found traces of volcanic ash and mercury, clear signs of those epic eruptions. There were carbon signatures showing huge spikes in carbon dioxide levels, making the atmosphere toasty and the rain pouring down. It all happened in 4 separate pulses, each triggered by those monstrous volcanic blasts. There's a spot in a national park not too far away from Sydney, Australia, where a fire has been raging deep underground for at least 6,000 years. They call it Burning Mountain, and it's a coal seam fire, burning its way through a layer of coal beneath the Earth's surface. Once these underground fires start, they're pretty much impossible to put out. This ball of fire is up to 30 feet wide and extremely hot, but there's no flame, it's smoldering. The fire has been creeping along at a pace of about 3 feet per year. A local farmer first spotted it in the 19th century and thought it was a volcano. The people who have lived here for ages believe this place is sacred. They've used it for cooking and crafting tools, and tell that it started from a widow's tears or the torch of a hero. But experts think it could have been a lightning strike or coal heating up like a summer barbecue from the interaction with oxygen. Some say it might have been burning since before the dinosaurs roamed the Earth. No one knows exactly how long this mountain will burn or in what direction it'll move. Right now, the coal has enough oxygen to burn for centuries or even millennia without human intervention. The fire is heating up the mountain like a giant oven, making it crack and crumble, inviting in more oxygen to feed on. Even if humans decide to take action, these coal seam fires need truckloads of water and liquid nitrogen to tame them. Several years ago, explorers noticed that the smolder was creeping close to a cliff overlooking a little river, and depending on what the coal seam decides to do next, we could see some dramatic changes here in the coming decades. There could be flames with much more heat, or the coal seam could go deep, extinguish itself, and smolder out.
A magnitude 15 earthquake has the potential to completely destroy our planet and evaporate all the water in a matter of seconds, leaving Earth uninhabitable. Over 500,000 earthquakes happen annually, but none have a magnitude of 15. 90% of quakes occur in the terrifying Ring of Fire zone located around the Pacific Ocean. The ground there is like jello. It shakes almost constantly. The most powerful earthquake to have ever struck Earth had a magnitude of 9.5. That much power can lengthen or shorten the day. But there's probably an earthquake in the confines of your own home now caused by a speck of dust landing on a table. But it has a power of negative 15 magnitudes. Earthquakes happen when tectonic plates move. They're like Lego pieces that are not properly secured, and when they move up, down, or hit one another, the ground also moves, triggering earthquakes. This tectonic energy acts like a battery. It stores energy for a long time, up to 500 years. When this stored energy is released in a sudden burst, the consequences are horrifying. Even the strongest structures submit to this relentless force that leaves a trail of destruction in its path. In some instances, earthquakes can even trigger tsunamis, amplifying the chaos. Such a crazy amount of power can split the ground open and cause severe damage. The strength of an earthquake is measured by the Richter scale, but now it's being replaced by the moment magnitude scale. When there's an earthquake, we hear about how strong it is. It's usually from 1 to 10. Luckily, we haven't had a Richter scale earthquake yet. The most powerful earthquake to have ever happened in modern history occurred in Chile in the 60s. It was around 9.5 on the Richter scale, and it altered Earth's rotation and messed up the length of the day by around 2 milliseconds. It also triggered a massive tsunami and affected a vast area of 155,000 square miles. The Richter scale doesn't actually have a limit. Still, anything above 25 doesn't need measuring, because if that ever happened, we would simply turn into dust, and nobody would care to measure this disaster. As we said, the strongest earthquake had a magnitude of 9.5. If this magnitude had been just 0.5 stronger, it would have created a ruptured line 2,174 miles long. That is almost 7 times the size of Wyoming. A magnitude 11 earthquake would create a crack halfway around the world. Massive tsunamis would hit coastal areas, destroying everything, and Earth would get into a massive environmental crisis. If you love hiking, you would have new mountains to explore, created by the terrifying earthquake. Even the temperature would increase because of volcanic eruptions and the resulting greenhouse gases. It would turn our planet into a hot oven. The safest places would be far away from any buildings, seas, oceans, and mountains where there would be a low chance of a landslide. Countries unprepared for earthquakes would be totally destroyed, and cities would turn into piles of rubble and dust. Going up on the Richter scale would only make things worse. But don't worry, an earthquake of that power is impossible. Earth's crust doesn't have enough energy to produce such earthquakes. But there is something that has much more power and can produce mega earthquakes. Asteroids are powerful enough to destroy our planet, as we all know from the dinosaur era. That asteroid was around 6 miles long, and it caused massive damage to the planet. It triggered earthquakes that shook the ground constantly for months. These terrifying quakes were about 50,000 times stronger than the Chile earthquake. They also triggered a tsunami that was 30,000 times more powerful than the Indian Ocean tsunami. And the latter was one of the most devastating tsunamis to have ever struck Earth. The earthquakes caused by the asteroid had a magnitude of 11, making it the most powerful and scariest natural disaster ever. And let's hope it stays that way. The Indian Ocean tsunami affected only certain areas of the world. Meanwhile, the asteroid tsunami affected every part of the world and had 33-foot-tall waves. Even if you had traveled to the most remote place on Earth, you wouldn't have been able to hide from this Grim Reaper. A 15 magnitude earthquake wouldn't be 15% stronger than the Chile earthquake. The scale doesn't work like that. It would be around 100 million times more powerful than a 9.5 magnitude quake. It could make all the water on Earth evaporate, leaving us devastated and without any H2O to survive. All ecosystems would collapse, all food chains would be broken, and only some super strong bacteria would probably survive the impossible. That is only a fraction of the frightening things that could happen. The ocean is like the AC for our planet. Without it, Earth would be super hot. The ocean also serves as a shield from the sun's powerful rays. It acts as a heat absorber and cools Earth. Scientists think that the most dangerous thing would be the inability of Earth's crust to survive the violent shakes of the 15 magnitude earthquake. If our planet miraculously survived and didn't turn into dust, there would be massive openings in its crust. The ground would become gelatinous. It would randomly move up, down, left, and right, and no building would survive that. Our civilization would be brought back to the Stonehenge era. Tectonic movements like this are devastating. A similar thing happened in Japan when tectonic plates moved 165 feet from each other and then snapped back together, creating a 9 magnitude earthquake. No place on Earth is immune to this bone-chilling natural phenomenon. Still, certain places have higher chances of being destroyed than others, like the Ring of Fire, where 90% of earthquakes happen. This is a place where earthquakes are almost everyday occurrences. The Ring of Fire is located in the Pacific Ocean. It forms a ring around the continents that surround the Pacific. There, several tectonic plates meet, creating highly unstable ground. To make the problem much more terrifying, 75% of active volcanoes are located in this area. 90% of dormant volcanoes are also there, making this place extremely dangerous. Scientists carefully study this region to find a way to predict when the next earthquake might strike. The Ring of Fire is not the only place at risk of earthquakes. In California, along the San Andreas Fault Line, 2 tectonic plates have been storing power for more than 200 years. The San Andreas Fault is 715 miles long and has the potential for a massive earthquake. This region has its fear of violent earthquakes like the one that happened in San Francisco in 1906. It had a magnitude of 7.8 on the Richter scale. Scientists' predictions are terrifying. They say that the chance of a 6.7 magnitude earthquake is very high in the area. If all hell starts to break loose, you should know how to survive. Avoid anything that might fall on you, like windows, closets, or unstable ceilings. The official phrase from emergency experts is drop, cover, and hold on. Stay low to the ground. Hide under something stable like a table, and remain there until the shaking stops. Make sure to stay in your shelter for another minute or two, just in case there are aftershocks or loose debris. Use your nose and smell for gas. If you do smell it, don't turn the lights on or do anything that might ignite it. Stay strong and be safe.
An earthquake in Indonesia began in 1829 and lasted a mighty 32 years. It reached its climax in 1861 and hit a magnitude of around 8.5. It was caused by the tectonic plates below the island slowly clashing against each other. Researchers discovered that the quake had been building for some time after analyzing the coral in the area. They found it was being periodically exposed to the open air. That was caused by the gradual earthquake moving the land up and down. Scientists call these decades-long silent earthquakes slow slip events. A single lightning bolt can warm the air to around 54,000 degrees Fahrenheit. The heat makes the air expand quickly, creating a shock wave or boom, which we know to be thunder. There are close to 3 trillion trees on Earth. That translates to roughly around 422 trees for every person. Before humans, the number was nearer to 6 trillion. Almost 70% of the Earth's surface is covered by water, which on average is around 2.5 miles deep. 97% of Earth's volcanoes lie underwater, as well as the mid-ocean ridge, a massive mountain range that is over 40,000 miles long. Humans have mined around 190,000 tons of gold from the planet. Experts predict there is around 20% still left to be mined, but this figure is constantly changing. The world's largest active volcano is in Hawaii. Called Mauna Loa, it's over 2.5 miles above sea level. Given that most of it is underwater, the volcano's summit is a staggering 11 miles from its base. That's the same length as over 160 football fields. The highest ever recorded temperature on Earth was a sweltering 136 degrees Fahrenheit. It was recorded in El Azizia, or modern-day Libya, on September 13, 1922. The lowest temperature was a chilling minus 129 degrees Fahrenheit, recorded at Russia's Vostok Station in 1983. Earth is the 5th largest planet in the solar system, behind Jupiter, Saturn, Uranus, and Neptune. It has a circumference of roughly 25,000 miles, and it would take the average person around 8,300 hours to walk around the face of the Earth. The separation between Earth's land masses would make such a trek almost impossible, though. It takes 365.25 days for the Earth to orbit the Sun. Because our calendar years only have 365 days, we add an extra leap day every 4 years to make up for the difference. Russia is the largest country on the planet, with a total area of about 6.5 million square miles. It encompasses more than 1/8 of the Earth's inhabited land area, but still has a relatively small population given its size. Earth is the only planet with one moon. Mercury and Venus have no moons, while every other planet has 2 or more. Earth is over 4 billion years old. Scientists calculate this by looking at the planet's oldest rocks, as well as meteorites that have crash-landed. They used meteorites as they were formed at the same time as Earth, when the solar system was forming. The ground we walk on is basically recycled. The planet's rock cycle turns igneous rocks to sedimentary ones, then transforms those into metamorphic rocks, and back again. Like Earth, our moon also experiences earthquakes. They're less common and intense than the ones we have, and are caused by tidal stresses. A tidal stress is basically the relationship between the gravitational pull of the moon on the Earth and that of the Earth on the moon. Despite being the 5th largest continent, Antarctica holds 70% of the planet's fresh water and about 90% of its ice. Bangkok is the most visited city in the world, boasting 23 million visitors in 2019 alone. Paris, London, Dubai, and Singapore make up the other cities in the top 5. The lowest layer of Earth's atmosphere is called the troposphere and is the reason we have weather. Sunlight heats the planet's surface, which causes warm air to rise up to the troposphere. This air then expands and cools as the air pressure decreases and sinks down, where it is then warmed by the Earth again. Coral reefs are the largest living structures on the planet, with some even being visible from space. Coral reefs hold the most species per area of any of Earth's ecosystems, even more than rainforests. Earth got its name around 1,000 years ago, and it comes from the German word meaning the ground. But there's no evidence to show who actually named it. Of all the planets, Earth is also the only one which is not named after a Greek or Roman deity. The deepest point of the ocean is the Mariana Trench. It's a whopping 7 miles below sea level. Coastlines cover about 20% of U.S. land, but are home to more than 50% of the U.S. population. The Earth isn't actually a sphere. It's more like a squished ball that bulges at the equator. The bulge is caused by the force of the Earth spinning, which makes the north and south poles slightly flat. The Earth spins on its axis, which is basically an imaginary straight line. Earth has seasons because the axis is tilted, causing the sun's rays to hit different parts of the planet more directly, depending on the time of year. If the sun was as tall as a standard door, the Earth would be around the size of a nickel. The Earth's rate of rotation is gradually decreasing. It's happening so slowly that it would take as much as 140 million years for the length of a day to increase to 25 hours.
Get equipped for any season with brand new Brightside merch. Click the link and grab your print.
The biggest animal on Earth is the Antarctic blue whale. It can reach lengths of 100 feet and weigh up to 400,000 pounds, which is around the same as 33 elephants. The temperature at the center of the Earth is around the same as the surface of the Sun, at almost 10,000 degrees Fahrenheit. Earth is around 10,000 times older than humans. Earth is around 4.5 billion years old, whereas humans have been around for, at most, 450,000 years. There are around 34,000 known species of fish. The actual number is way higher though, as a whopping 95% of our oceans still haven't been explored. America's Route 66 is longer than the journey to the Earth's core. The distance to the core is roughly 2,000 miles. Route 66 is almost 2,500 miles. The Earth is made up of three main components: the crust, the mantle, and the core, which is divided into the outer core and the inner core. Scientists have estimated that there are around 8.7 million species on the planet. Out of this, between 1 to 2 million of these species are animals. But roughly 86% of land species and 91% of fish have yet to be discovered by humans. Ancient astronomers used to think that the Earth was the center of the universe. For 2,000 years, they believed the Earth to be static, while other bodies traveled in orbit around us. In 1543, Copernicus published his sun-centered model of the solar system. Earth is the densest planet in the solar system. The density varies across its different crusts, but the planet's average density is just over 3 ounces per cubic inch. Mount Everest is the highest point on the planet. Its peak is the highest altitude above sea level at around 5.5 miles. Each year, 1 septillion crystals of snow fall on Earth. That's a trillion snowflakes. Snow covers about 31% of Earth's land area each year. Of Earth's water, only around 3% is fresh water. The other 97% is salted. Of that 3%, about 2% is frozen in ice and glaciers. So, less than 1% of the planet's fresh water is actually in lakes, rivers, and underground. The world's largest inland body of water, or lake to us normal people, is the Caspian Sea. It has an area of 140,000 miles squared. The world's deepest lake is Lake Baikal in Russia and is 5,300 feet deep. Earth's atmosphere is roughly 78% nitrogen and 21% oxygen, with small amounts of water vapor, carbon dioxide, and other gases. No other planet is believed to have this much oxygen, which explains why Earth is the only planet where life has been discovered so far. Apart from the Moon, there are 2 asteroids in co-orbital orbits with Earth, sometimes called Earth's second moon. 3753 Cruithne is an asteroid that looks like it's following the Earth in orbit, but it's actually following its own path around the Sun. 2002 AA29 is another asteroid which makes a horseshoe orbit around the Earth that draws it close to the planet every 95 years.
It happened in Iceland on Friday, March 19, 2021 at 8:45 p.m., about 20 miles southwest of the capital. Molten rock suddenly burst through the surface from below. Bright lava fountains then lit up the night sky. A volcano in this valley finally woke up after almost 800 years of sleeping soundly. We divide volcanoes into 3 categories: active, dormant, or extinct. Around 1,900 of them around the globe are considered active. That means they've erupted in the recent past and will likely do it again in the possible near future. Dormant volcanoes haven't popped off for a long time, but they still may in the future. You could say they're sort of sleeping. As for extinct ones, those guys haven't done anything in more than 1 million years. The eruption in Iceland wasn't super explosive, and this all happened 6 miles from the nearest town, so everyone was perfectly safe. Many even came to see it up close, while other brave visitors tried to fry eggs and bacon on the lava. Just be careful not to burn your breakfast black. Lava can be over 2,000 degrees Fahrenheit. It burns everything in its path. Yet it also produces some of the most fertile land for agriculture. This eruption gave a relatively small amount of lava at first, but it's been spreading across the valley in different directions, forming a sort of shield that's constantly growing. You can never really predict how fast a lava flow will be until you see it. It all depends on how thick it is and how steep the mountain slope. Lava can ooze slowly at about 20 feet a minute, a fraction of the average person's walking speed. Or it can flow as fast as 30 miles per hour, which even the fastest person on Earth can't outrun. But the lava isn't even the most dangerous thing about volcanoes. That would be the toxic gases spewing from the eruption. And those spread faster and further than the lava flow. Luckily, in Iceland's case, the wind has been blowing these gases away from residential areas. Scientists weren't surprised this volcano erupted. They knew it was coming. Increasingly stronger earthquakes had been shaking this area for the past 15 months. There were 50,000 earthquakes within just the 3 weeks leading up to the eruption. That's 100 per hour. The volcano has been active since March, and geologists say this could last for weeks, months, years, or even decades of constant eruptions in the area. Mount Shasta is in the top 5 most dangerous volcanoes in the U.S., so geologists are keeping a close eye on it. The last eruption was in 1250. I wasn't around then, but this volcano erupts every 600 to 800 years. Which means tick-tock, we're due any day now. About an hour from Portland, Oregon, there's an active volcano that last erupted in the 19th century. Next time it goes off, scientists think it'll produce larger amounts of ash and dust. This could cause an electrical blackout and make water unsafe to drink in the area. But the experts pay close attention to Mount Hood. They'll be able to give plenty of warning so people can react in time. Kilauea is one of the most active volcanoes in the world. It's been erupting almost constantly since 1983, making it also one of the longest eruptions known on Earth. It's the youngest land volcano in Hawaii. Volcanoes can take thousands of years to form, but others can pop up practically overnight. A volcano in Mexico just erupted in an open field in 1943 and started growing from there. Within a year, it was almost 1,500 feet tall. When the eruptions finally stopped 9 years later, the mount had reached a height of over 9,200 feet. Mount Fuji is an iconic symbol of Japan. The last time it erupted was in 1707, and it sent a shower of burning rocks as far as 60 miles away. If a similar eruption happened today, Tokyo would be within that vicinity. Mount Fuji is right on the Ring of Fire, that horseshoe-shaped region in the Pacific Ocean full of active volcanoes and earthquakes. From one end to the other, it's almost 25,000 miles long. It could wrap all the way around the Earth's equator. In January 2020, Taal volcano in the Philippines started spewing lava, sending huge plumes of ash half a mile up into the sky. The eruption even triggered a rare phenomenon, a dirty thunderstorm. That's when the smoke cloud above a volcano produces its own lightning. The chance of volcanic tsunamis was also high. Those are usually caused by tectonic movements that occur because of volcanic activity. Taal has erupted more than 30 times in the last 450 years. This volcano in Ecuador last erupted in 2016. Scientists think it might be showing some early warning signs of magma on the move. This is an active stratovolcano, a specific cone-shaped type with steep sides. They form from sticky lava that doesn't flow that easily. That lava goes around the vent, cooling and piling on itself to form these steep walls. These types are more likely to produce explosive eruptions like the ones we see in movies. Ruapehu is the oldest national park in New Zealand, a volcanic wonderland where you can closely see all those steaming craters, magnificent lakes, and unusual rock formations. It last erupted in 2007 and has had 10 eruptions since the mid-19th century. But eruptions, lava flows, and toxic gases aren't the only danger coming from volcanoes. There's also a thing called lahar, a kind of volcanic mudflow of debris. In between eruptions, snow melts and a lake forms in the caldera. If the last eruption brought mud, ash, and rocks in the lake, it becomes dangerously full. In that case, only a temporary dam holds it back. Indonesia has the biggest number of active volcanoes in the world, including one called Anak Krakatoa. It means child of Krakatoa, and its famous parent isn't far away. A huge tsunami in 2018 partially woke Junior, a scary thought since Senior had one of the most powerful eruptions ever seen on this planet in 1883. Krakatoa's boom was the loudest sound ever heard. People over 2,000 miles away could hear the explosion. The sound wave circled the globe 7 times, and scientists say it's hard to predict this volcano's eruption patterns. Mount Yasur in Vanuatu is one of just a few volcanoes in the world where you can see a lava lake. Tourists even go there to peer over the edge and get a look at the burning, bubbling lake below. Well, except for when the volcanic activity goes to levels 3 and 4 out of 5. That means there are more intense earthquakes, volcanic tremors, or steam, gas, or ash ejections. Then this place is off limits because, duh. This volcano in the DR Congo has the most active and largest lake volcano in the world. And all that lava is unusually fluid, meaning it travels faster and further than the stuff coming out of most volcanoes. It's certainly not amongst the tallest ones, but Ethiopia's Erta Ale is unique in that it has a lava lake almost constantly, which is pretty rare. The locals call it a smoking mountain because its lava lake often causes eruptions. This volcano is near the Danakil Depression, one of the hottest places on our planet. Merupi has been erupting on a regular basis since the mid-16th century. This volcano helps scientists do crucial research on how eruptions work and how they can warn people in time. After it was dormant for a while, this volcano in central Mexico sprang back to life in 1994. Ever since then, it's been producing huge mud flows and strong explosions in unpredictable intervals. In the past, enormous eruptions coming from this giant buried entire cities in pyramids. Imagine staying in a hotel and waking up to the magnificent view of a massive volcano covered in glowing rivers of lava and clouds of ash. When it lets off heat, visitors to this area in Guatemala take a chance to roast some marshmallows there. One of the most active volcanoes on Earth is on a small island north of Sicily. Stromboli has regular explosions, together with glowing lava coming from vents inside the crater. Not too far away is Etna, Europe's most active volcano and one of the biggest continental ones in the world. By the way, Earth definitely isn't the only planet with volcanoes. The largest one in our solar system is on Mars. It would cover the entire state of Arizona, and it rises nearly 3 times higher than Mount Everest. Ooh, don't look down.
The floor starts quaking like it's alive. Books, mugs, and lamps leap off shelves. Your feet slide, your body sways, and you can barely stay upright. It stops for a second, but then it shakes again and again. More than 1,000 times just in one day. This is not how you imagined your trip to Santorini, but it's the new reality. The Santorini seismic swarm started in January 2025. In less than 1 month, there were, get ready for it, more than 20,000 reported earthquakes. For comparison, most cities on Earth go through one small, barely noticeable quake in a year. It all started with small jolts that residents could feel, but tourists might have mistaken for large trucks driving nearby. But by February, things got serious. A magnitude 5.3 quake struck. It's a moderate-strength earthquake, but it was strong enough to rattle homes, break windows and dishes, and terrify the island's population. The Greek authorities declared a state of emergency for Santorini and Amorgos. Thousands of people had to leave their homes. Schools closed, and hotels temporarily evacuated their guests. Santorini is famous for its volcano. the one that blew up in a massive eruption around 1600 BCE and inspired the legend of Atlantis. It's still considered to be active, although there have been no significant eruptions since the 1950s. So it would be logical to blame this monster for all the drama. But nope, these tremors weren't volcanic. Experts said what was happening near Santorini looked like a seismic swarm. It's a series of smaller quakes all happening in the same area. They are happening along faults, which are cracks in the Earth's crust that can suddenly shift when the tension gets too high. Think of the ground like a giant, stressed-out Rubik's Cube. At some point, it twists and snaps somewhere. Near volcanic areas like Santorini, fluids moving underground can sneak into these cracks and make them easier to break. Plus, there's the natural stress from tectonic movements. It's like adding oil to a squeaky, overworked hinge. Suddenly, everything slips. Nobody knows exactly what's coming next. Tracking thousands of tremors isn't easy. Many of them are too small for traditional seismic sensors to pick up. But this time, scientists have their new best friend to help out. I'm talking about artificial intelligence. Thanks to machine learning, researchers can detect patterns in tiny vibrations that humans might miss. This technology has helped a lot to understand the swarm. It lets scientists map which parts of the crust are most active and even predict possible future activity. The AI analysis suggests the quakes aren't random. They seem to be clustered along a fault line near the underwater Colombo volcano. This area has a long history of seismic activity. Even though Colombo hasn't erupted recently, the magma beneath it might be subtly shifting the crust, and it adds tension to the tectonic plates above. It's like a simmering pot. Nothing boils over yet, but the heat is definitely building. The swarm has subsided after a couple of months of constant shaking, but it doesn't mean it's over for good. Even after a lull, another swarm could strike, or a larger quake could happen along the same fault lines. That's why scientists are now studying the data collected from the swarm. If you're thousands of miles away from Santorini and don't have plans to visit, it doesn't mean you're 100% safe from a similar scenario. Seismic swarms like the Greek one happened in the Caribbean, Iceland, and Italy. One of the best documented swarms in history happened in Japan, in a suburb northwest of Tokyo. It was all going on in a town sitting on a seismological observatory, like a secret underground lab for tracking earthquakes. The swarm kicked off in August 1965 with just 3 earthquakes that were so weak nobody could feel them. But things escalated fast, and 3 months later, 100 quakes a day were strong enough for people to feel. On one day, the observatory recorded almost 7,000 quakes. Out of those, 585 were strong enough to actually shake the ground, meaning you could feel a quake roughly every 2.5 minutes. Scientists figured out that the swarm was caused by fluids moving underground, kind of like the Earth's crust, stretching and bubbling. Studying seismic swarms helps scientists predict earthquakes better, understand how Earth's crust moves, and even prepare for future natural disasters globally. For instance, if they can link the patterns of tremors to magma movement or tectonic shifts, they can apply similar models to volcanoes and fault lines in Hawaii, Iceland, or the Pacific Northwest. Santorini is like a living lab where they combine modern tech with traditional knowledge. AI, seismographs, and satellite imaging add to centuries of human observation. The locals who have lived through quakes for generations contribute insights about small tremors, changes in groundwater, and unusual animal behavior. All this helps scientists refine their models. Santorini's swarm has surely grabbed the attention of the whole world, but it's not the only place on Earth with some intense seismic activity. But what makes Santorini unique is its combination of historical volcanoes, underwater fault lines, and the fact that it's a real tourist magnet. The island is not so large, and the effects of even moderate tremors feel stronger and more dramatic than in other regions. In other places, though, even more serious earthquakes, tsunamis, and volcanic activity are regular news, and the people have learned to live with them.
Japan is one of the regions on Earth where earthquakes happen the most because it sits on the edges of 4 tectonic plates. There are around 1,500 of these earthquakes each year that are noticeable. Because of this, the people in Japan have learned to live with earthquakes. There's even a law that sets a rule that buildings in the country should be able to handle earthquakes up to a magnitude of 7 without falling apart. An update 30 years later said that buildings should only have minor damage in such earthquakes and still work as usual. But if an earthquake is even stronger, the law says the building's main job is not to collapse, but to save people's lives. At the most basic level, buildings are made stronger with thicker beams, pillars, and walls so they can handle shaking better. They even construct some buildings on thick layers of padding that separate them from the ground completely, which helps protect them during an earthquake. A skyscraper might sway back and forth a lot and move up to 5 feet, but it won't collapse. On the other side of the Pacific, scientists from the U.S. Geological Survey have studied a dangerous area along the U.S. West Coast. It's called the Cascadia Subduction Zone. Over the past 14,200 years, there have likely been at least 30 big earthquakes in this region. One major quake happened every 500 years on average. But for a long time now, Cascadia has been quiet, and the scientists are getting worried. They think this might be because the area is locked, so the tectonic plates are stuck together and building up a lot of pressure. At some point, a part of the seafloor could suddenly break and move forward by several feet. The shaking would be just 5 minutes, but it would create a powerful tsunami as the seafloor shifts that would last for 10 hours. If it happens, it's going to be the worst natural disaster in the country's history, according to experts. This could make the hillside slide and crumble and take down roads and bridges. Around 620,000 buildings could be badly damaged or even collapse. Scientists are hoping that thanks to advanced AI tech and local communities, they'll be able to better predict earthquakes like this and the one in Santorini. This could save thousands of lives. And for now, we must not forget that the Earth doesn't take vacations when it comes to seismic activity, even in places where you go on vacation.